speaking with the people on the ground and the different perceptions these people have. I would now like to enter a joint discussion here on the topics of interest. And one of the takeaways I got from Richard, but also from other contributions here, is that although we like to speak about water scarcity, and it's like a media topic, there's actually a more differentiated evidence in suggesting that the indicator that is often used is flawed, and there are more sources of supply available than media attention suggests in a way, which is basically storage or reservoirs, but indeed also the potential of, say, water productivity here. And one of the kick-off questions is still a bit related to this sort of fundamental question, and it relates a bit to one of the slides that Carol has used, where I got from Richard that there are still many uncertainties on what is the potential of water storage and how would these replenishment mechanisms work. While one of your slides, Carol, suggested we can actually have like two worlds. One is a world with water storage stress, and the other part is the countries or the regions which are not or less under stress. You had like blue and red colors. So could you eventually say a bit more about the uncertainty that you probably also faced when you draw this map? About the uncertainties dealing with water storage.
So actually that map is from a different, the background that I used for that map was from a different study that is called Groundwater Footprint, published Glisson et al. Nature 2012. So I cannot say much about the storage. What happened in our study, we don't have storage actually, because this is one of the most, as we shall say, uncertain variable in terms of groundwater systems. So in my study, in our study here, we just look at the recharge and the abstraction, so just the fluxes, not the storage, exactly, because it's like one of the most challenging things, but it's ongoing efforts, both improving the current estimates of fluxes, including recharge and abstraction, so the depletion estimates, and also improving and creating, because they don't always exist, estimates of the storage in ground. So I think Richard can say a bit more about the storage than I can. Yeah.
I suppose the one point there's several things that you've raised. So but the one point I was trying to make in the talk is that just a kind of a reality check that we do have, there remains, and there's still a lot of work to be done. A lot of work to better understand fluxes in different areas, but I'm not sure that was at the heart of your question. Was it? Was it a little bit more philosophical? I mean, so there's uncertainties. There's uncertainties in our computation of resources, replenishment, mechanisms by which these all take place. Certainly, that's there, and that will be there for, and that will continue to be, and we strive for that. I think what I was also trying to get at in the talk is that how we actually construct our understanding of scarcity and what role does it play. And I mean, many communities are extremely resilient to scarcity, and so I'm always a bit nervous about, I'm not suggesting any of the speakers were suggesting it, but you know, kind of simplistic things about where scarcity immediately means a problem. As we all know, from the work of people like Amartya Sen, of course, that you know, show me a famine, I'll show you dysfunctional government. There is not that there was a lack of food; it was that there were, you know, entitlement. So a little bit about that. But one of the bits you mentioned was how do we actually define scarcity, and what role then does it play from a policy level? I think that's important. You see, I don't know whether people in the room have this feeling, but I felt that, oh yeah, another paper, high-profile paper saying the number of people who will be living under conditions of water stress in the next 20 years. And then think, okay, what do you do with that? What does that actually inform anything? Or is it just a bit of a lovely story that simple story, journalists can publish, you know, we can circulate the story around, but what does it actually mean? And actually, and seriously, so I would suggest, I mean, sorry, I'm rambling here a little bit. Malin Falkenmark, who coined the original water stress index, has all but disowned it as an idea now. And she's with much chagrin, she looks and says, haven't you come up with anything better in 30 years? And she's thinking it's about time we retired this and we moved on with something a little bit more sophisticated. And she put it out there in the 1980s as a first step, maybe, or as a first tool. And it's just, in a way, it's been kind of blindly just applied for 3 decades. And so I think there's a conceptual angle where we need to improve what do we mean by this. And I gave an example where I was trying to move from a metric which just may give you a label to a metric which might actually inform, meaning that it might actually have policy implications. And then the other business about just uncertainty in our computations. Just a degree of humility about how uncertain these things are.
Well, thank you very much indeed. More questions to some of the speakers here. Thomas.
I was surprised not to hear anything about reuse. I've heard from many. I've heard from many people working in this area. I'm not a water expert myself, but reuse is the new supply. And you look at Israel, for example, as the extreme case. It really is a prolific source of new water, especially for agriculture. It does get one into that nexus between quality and quantity. It's really, I guess, maybe you could just comment on, I'll look to you first, perhaps the others as well. Why didn't any of you talk about reuse of water as a source of supply?
I'll quickly say, I work in areas where there isn't a tremendous amount of grey water that's being collected. Meaning, so I have a bias. I work most of my experience has been working in low-income countries, primarily in East Africa, but also in South Asia. So though there are possibilities here, in more developed economies, if you want to take it that, but I don't know whether that's the right word to use, I would just say in areas that have reticulated sewerage, in areas where grey water effluent is more feasible, then yes. I mean, if you look at, maybe to give you a bit of a context, in some of the cities that we work in, there isn't reticulated sewerage. It is dominated by on-site systems. So in a way, they're incredibly efficient. They're not producing huge amounts of grey water for reuse. I would agree with you that yes, there is certainly room for this, and that should be part of the conversation. And actually, it was originally in one of my slides. But anyway, the idea is using green and grey water in addition to considering green and grey water in addition to blue water. But I just think it's contextual. And if a particular country is not necessarily correcting large amounts of grey water, then there is more limited of a resource to then use.
Yeah, I mean, I think it's maybe more relevant in the context of urban or industrial use of water, because we've all talked about food, agricultural use of water, and in this case, the volumes that you need is on a very different scale than the volumes you get out of, from wastewater, from cities or industrial use. But something that is very important in agriculture, especially in irrigated agriculture, is how much you lose the efficiency just from the withdrawal to the field. In places in China, you lose 70% of the water that is extracted along the way. So, as hydrologists, you say, well, it returns in the natural system, so that's fine. But, there's still, you could just withdraw much less from the original source. If it's a groundwater, that's a big problem, because it probably won't go back to the actual origin. So, yeah, efficiency is also a big potential source in improving efficiency.
Well, just a quick comment on the reuse issue also from my side. When we look at totally different system where reuse has been established, like in a metal recycling area, we see that the actors themselves have started to think much more in circular economy, circular loop terms. And I'm not sure whether this already exists in the water area, or at least in my understanding there seems to be very much a linear thinking. From you supply, you distribute, and then you have the wastewater, so there's less of a circular economy idea around. And then probably the price matters too. With metals we know that the price quite often is high, it's not always, etc., etc. But water prices are either unknown to many people, or they are artificially low, like in one of the cases we've heard. So one of the bigger motifs to establish, to invest into circular economy reuse systems is weaker. And so there are lots of stories where we can eventually also learn across resources, like from metals onto the water area. And I suggest to take this question forward. There was another statement here, yeah. Oh, that's you, yeah. Sarah, I see you.
I would like to ask you, as you know, biological system is also very important for the water cycle. You didn't mention a lot about the biodiversity and where there is lost, how it will affect water scarcity. And is there any projection about that? How that will affect water scarcity?
If I understood, again, although we have a microphone, even though my hearing is poor, you're asking a question about the biodiversity, is that what?
Yeah,
and the relationship to, let's say, environmental flows and the sustaining of that, and the sustaining of that. Yes. I mean, one thing that I would there has been quite a bit of work, simple work, but quite a bit of work, where people have tried to embed, in addition to a freshwater demand, say for agriculture or for industry or for domestic purposes, people have been building in an environmental water demand or in-stream water demand as part of a total freshwater demand in their calculations. So this is being done, particularly with people who have been using models to essentially construct. But the one thing to recognize is that any of these estimates that are being done at the right are comparatively simple. So from a biologist's point of view, you would struggle to find, you would recognize that it's kind of a tacit recognition that environmental flows are important. But as you probably are aware, a rigorous analysis of environmental flows takes quite a bit of resources and detailed local information. So when we are thinking about large, broad brush, if you want to say, assessments, they are often based on things like minimum flows or particular flow percentile, and they're done comparatively crudely, but they are being done. But I just say I don't know what biologists necessarily think of them, but they are generally about maintaining low flows and particular flow percentile as part of an assessment of environmental flows more largely. But yeah.
Directly related to this?
Yes.
All right, then step in, and Sarah is then the next one. Okay.
Andrew Ross from Global Garden. Natural capital accounting is now central to the way DEFRA is approaching evaluation of flood alleviation here in the UK. There is a huge amount of work on the economic value of biodiversity and ecosystem services that is actually being implemented, down using satellite imagery, right down to the single tree held by a local authority. Just look at DEFRA's natural capital accounting and you'll find a wealth of material for valuation of catchment areas.
I'm sure this may be the case in the European context. I guess the difference that I'm responding to is at a global scale and in many other parts of the world, this sort of analysis is not there, but particularly prompted by the European framework. Yeah.
Thank you. Sarah?
Thanks, Raymond. I'm Sarah Bell from Civil Engineering here at UCL. I just wanted to come back on this idea about the circular economy, because I think in many ways water is the original circular economy. You know, it's all, with the exception of fossil groundwater, it's all recirculating. And indeed, in a catchment like our own, we're already reusing water that's been used a number of times already upstream. And I think there's also the comparison between metals. There's a physical contradiction there, in that if you take virgin ore, that's perhaps the most polluted of metal sources. You put in an awful lot of energy to get a metal that you can use, and then metal that has been used is already, it's less energy intensive to recycle that than it is to start with virgin ore. Whereas for water it's the opposite, because wastewater is actually, in most cases, much more polluted than certainly groundwater. So the energy intensity of cleaning up wastewater is much higher than treating natural groundwater or even natural surface water. So I think we just need to be a bit careful with some of the kind of physics and the economics of making those comparisons across sectors.
Thank you.
My name is Nicholas from Ahmed. I was curious, there was no reference to the growing of cotton or other forms of fibre and indeed trees and bushes. I wonder how that affects the situation in areas where there is a real shortage of water. For example, I'm particularly concerned with Tamil Nadu in southern India. Would it have a significant impact to be using if you like, land with low amounts of groundwater for growing products like industrial hemp, which uses much less water than cotton? I thought that cotton had a huge impact on the consumption of water, and it was probably rather a bad thing. So I was intrigued that it didn't get mentioned. I also thought that trees could have a huge impact on reducing, say, the need for air conditioning and therefore use of energy. So how does that come into the equation?
So we actually have cotton included in that study on groundwater depletion for crops irrigation. We don't have trees. I mean, obviously, because we're talking about irrigation, we're just looking at irrigated crops. But cotton is one of them, and it's actually been included because it plays a very important role, even though it's not a food crop per se. So yeah, in some countries on the maps that I showed, like it's up to a quarter of the country's groundwater depletion for irrigation that goes to cotton. So in India it's very important, Pakistan, in the US, in Australia, yeah. So cotton is a big consumer of water. Yeah.
So if one could grow something like industrial hemp, which uses a fifth of cotton, it would have a huge benefit.
I guess so. Yeah, I don't really know.
Sorry, can I just jump in here? That's one of the things we often get asked in Australia about annuals versus perennials. If you just increase, say, you can't grow cotton, you just increase the area under irrigation, water use doesn't change.
Interesting point. All right. I would suggest, well, the panel is still there. The time is already over, more or less, but I would like to suggest a quick round through the panel, eventually beginning here with Tony. And some last concluding words. What did you learn in this session? What's been most interesting to you? Then we go through the panel and then we conclude for a coffee break.
What was interesting to me is although water is one of the most important input in agriculture to Nebraska, it wasn't really valued that high for agriculture. It was, of course, farmers they're more interested in securing their yields than in the sustainability of the aquifer. But in long term, that's a big point for securing your yields, that you also secure the sources where you get your water from. But so far, yeah, it wasn't really looked after, the water supply, because also there's just so much in Nebraska, so why care?
That might be the case.
Thanks.
Tony, I believe that the issue of valuing water or a proper or a just price might be part of the next session, so I look forward to learning more about the valuation. Karen.
Thanks. Yeah, so I mean, I think we all, it all comes down to this question of pricing and valuing, and the problem, as we were discussing also with Thomas and Tony, is that you have all these conclusions that, look, we are not doing the right things in terms of environmental sustainability. We have to change, and we know where the problem is, so why is nothing happening? And so it's mostly because, yeah, this is free, this water is free, it's not. It's actually not even. It's not regulated in most places. It's not even measured. Like we don't even. Farmers don't even know exactly how much they pump. Only they know the cost that they pay for the electricity bill. But then you say, okay, so put a price on water, and that price is then reflected in the food that is produced with this water. But that's a problem because, okay, so farmers might be happier because they get more money, or maybe not because they pay for the water. But the consumers, that's the problem. Food affordability, especially in the future when under climate change, when the poorest will be most affected and won't have their own their own like family farming available, or they won't have any income to pay for extra food coming from the rest of the world. That's really a challenge I don't know the answer to, obviously, but I'm looking forward to the next session if that's the topic.
We look forward. It also reminds a bit to what Amartya Sen wrote, well, decades ago, where he figured out actually in one of his path-breaking studies that when prices go up, famine actually goes down because there is more supply on the market. So there might be a mechanism where prices might help, but I'm not sure whether this is what is also suggested by Alison's research.
Yeah, just to echo what she's saying, I think it is really interesting to look at it, across the way that we all study this, but taking into account the consequences of including the cost of water into the cost of food and what that ends up doing for the stability of the countries that it's going to. And in theory, certain countries will be able to absorb that cost through subsidies or through welfare programs, but the ones that have the less resources to be able to give those sorts of government programs are likely the ones where the populations are requiring the most assistance were we to incorporate the cost of water.
Yeah.
Again, I end on the same note, I don't know.
Well, it might also be an issue of urbanization. When Amartya Sen did his study, we were still living in a world with rural population, basically, where indeed the incentive to become farmer was then like a guarantee to livelihood. In an urbanized world, this looks slightly different. Richard?
Just really that there's lots of interesting challenges and opportunities, many of them that I was unaware of, and I think it's great to have such a diverse audience. We often have sort of more discipline focused meetings, and so having economists and social scientists and even hydrogeologists in the same room, and engineers, it makes for a very, very good mix. So I'm kind of looking forward to the discussions and that. And I think there's a lot of experience learning when you have this different disciplines getting together. So the questions have been very interesting from.
Well, thanks, Richard. Then the ball is in the field of Thomas and the next session. I really look forward to it. We now have a coffee break, so thanks to the panelists here.